So 4, here we go. 1 and 2 are reversible, that's protons and neutrons, doesn't matter which one's in which space. 3 is the nucleus, N-U-C-L-E-U-S, which is not the nucleus. That's not a word any more than nuclear is not a word. Nucleus, nuclear, those are words. So nucleus is 3. 4 is a mass number, 5 is neutral, 6 is an ion, 7 is energy levels, 8 is atomic number. That's our new ones. Question.
What was 5?
5 was neutral.
What was 8?
8 was atomic number.
For 7, would it be okay to include electrical level?
I'll go half. 4 up to 8. Then we had some 4-3 quizzes in the mix, so if you had a 4-3 quiz, you're now going to put your attention to number 9, which today is also number 9. So it's AMUs, we're carbon 12, we're 12 AMUs, we're Dalton. 13 to 15 is that elements are made of atoms. It's when atoms form molecules of compounds, they do so in whole number ratios. And then different elements can unite in different ratios to form different compounds is 13 to 15. Pause there, anything up to that. Then 16 to 27, as well as yesterday's 1 through 6, we'd have titles, proton, neutron, electron, were 3 points worth of titles. For charges, yesterday we did charges. A proton was +1, neutron was neutral or no charge, electron is -1. Yesterday paper, then 7 and 8, answers were mass and charge. But the today paper, we keep talking about categories. So proton, the abbreviation was a little p with a little plus exponent. As I said, that was a +1 charge, and it's a mass of 1 AMU. Neutrons is a little n with a 0 in the exponent position. That was, like I said, no charge, and that is also 1 AMU. Electron is the little e with the little minus, and that is a -1 charge, and that was negligible mass, which means there is some mass there, so it's not quite accurate to say it has no mass, but it's so little mass it might as well be 0 because it's not much going on. Question about scoring anything yesterday, today, whatever. So good news, bad news scenarios. The good news part of your scenario is that the read for tomorrow is very small. There is 1 new blank. So this quiz bounces from 27 up to 28. So that's your good news of the day. Bad news of the day, there's finally homework to do and turn in tomorrow. So what we're looking to turn in tomorrow is 1 to work from A to K, slip in a 2A and a 3A, and then 5 and 6 is where the majority of this is. Let me look at the page to make sure I'm giving you good advice. Yeah, 5 and 6, it's like A through F on 5 and 6. So it's like 12 questions, not 6. Syllabus knows all.
Okay.
So you can just grab that off the syllabus. But what's going on this homework, my little board piece right here, is they'll give you something like this, and they're going to ask you some questions about what's going on. So I don't think they make you identify. B stands for who? B for boron is correct. But what they do want you to do is say what's up with these numbers. So can anybody tell me what's up with those numbers?
5 is the atomic number.
5 is the atomic number. What does that mean?
That's the number of protons.
That is the number of protons. So this would have 5 protons. That is called the atomic number. The atomic numbers are on the periodic table from 1 to 100, whatever it's up to now. But hydrogen is 1, helium is 2, lithium is 3, etc. and so forth. But this counts the protons. That is the atomic number. Somebody else tell me anything about numbers here?
The 11 is the mass number.
The 11 is the mass number. Who contributes to the mass number? Protons and neutrons. So by process of doing a little bit of math, we would know that there are 6 neutrons. So they're going to want you, I believe, to list off in the homework like what's what. So that's not too much heavy lifting. But yeah, they want you to list protons and neutrons. Then they also want you to say how many electrons there are. How do you know how many electrons there are?
An atom's neutral, so same amount of protons.
Same amount as protons. So this would have 5 electrons as well. So that's what the homework is doing. 5 and 6 is the main part of the homework with some other scraps. Question about that? Quiz change things. So like I said, there's one new point about reading 4-5. From 9 down is pretty much keeping, with a small add-on to that last big question of describe where these things are. So you could describe where these things are with a picture. So if we're trying to describe where protons, neutrons, and electrons live, what would I draw for my picture? A circle that's called the nucleus. Yes?
Positive proton
Who's in there?
proton and
Protons live in, neutrons live in,
electrons live like a circle around it.
electrons float around, and that's a good enough drawing for me for now. But one thing we learned about on this quiz is the electrons float around, some of them in different spots, depending on how many electrons there are, and those were called energy levels. So if you only had like 1 or 2 electrons, they just live at energy level 1. If you had like 100 electrons, they'd be separated into all these different energy levels, and that's more of a conversation for another day of how do you know how many electrons go at the different levels and whatnot. But there's these different levels where the electrons live, but I'm okay with you just drawing me one level for the purposes of right now. I'm not real worried about that. Okay, so 1, 2, 3, that's going to become basically picture-based and included with the 16 to 27. Mass number will go backwards. So what was the mass number?
Sum of protons and neutrons.
Yeah, protons plus neutrons. So you could either use the word sum, or you could just put like an add symbol in your answer. If you'd rather have math symbols than words, go for it. But we're adding the protons and the neutrons together. That's the mass number. 5 is going to go away. 6 is going to go backward. What is an ion? That's if an atom gains or loses electrons. We talked about yesterday, the electrons are responsible for all the action that happens. The reason is, we'll go into the picture, for what obvious reason is it the electrons that cause the action?
Because they're on the outside.
They're on the outside. So you can easily pluck an electron off or throw an electron on. If you try to get at the protons or neutrons, what would you have to do?
Get
rid of
rid
the
of
electrons.
Yeah, you'd have to destroy the nucleus and slice this atom up. That's some heavy duty equipment to be splitting atoms. But the electrons are just floating around. They're more accessible. So if an atom gains an electron, what kind of charge would it have? Negative charge. And if it lost an electron, it
Positive.
has a positive charge. But if you have a basic atom, most basic atoms are electrically neutral. Electrons match protons. But if we do have an electron come or go, that's then not called an atom anymore, that's called an ion. So an ion probably started off its life cycle as an atom, but if it gains or loses some electrons and then starts to have some kind of charge on it, now it's called an ion. So that question goes backwards. Energy level is going to go backwards, start for number 7. So start with the word series and then talk. It's this series of areas outside the nucleus where the electrons are. 8, atomic number goes backward. What was the atomic number?
Number of protons.
Is the number of protons. to help you remember what the mass number is, just think about which things have mass. Which were the particles that had mass?
Protons and neutrons.
Protons and neutrons have mass. So the mass number is the protons and neutrons. Atomic number, it's not that, so what are we counting? We're just counting the protons. So protons are for atomic number, protons plus neutrons is mass number, and that is it for quiz, other than a little baby bit of trivia. I don't know if these reappear on the test as bonus questions or something, but I'll rattle you off a little bit of trivia. But question about the things that matter. So potential things that could matter someday if I activate these. A person is making some of these discoveries about what's where in the atom. Anybody with super reading comprehension pick up on who is this?
Was his name like Eldridge?
No, it's Ernest
Ernest
Same thing.
Rutherford.
Rutherford. So
Rutherford.
Rutherford might appear somewhere in a future thing. Rutherford is the one who figured out who's where. We're like just over the line into the 20th century with him. He lived 1871 to 1937, so he's around. Second little bit of trivia that might matter is the nucleus is super, super dense. It gave you the trivia of 1 milliliter, which is like a drop. If we just had like one little drip of water left in a bottle, it said how much that would weigh. Anybody with super memory of one little drip of a milliliter of water? Weight on that?
A couple of tons.
110 million tons. Egad. So one drip of water that's 110 million tons, that's
Pretty dense.
that's pretty
I
dense.
would know that.
Yeah, that's pretty dense.
I'd know that.
The other
Gotta be
thing
like
they try
trillions.
to do to give you some sense of scale is as to just what's where. This just sort of makes it look like, oh, the electrons are right there. But the nucleus is like so tiny, you get a little false sense of that maybe. The book described if you were a nucleus, where your electrons might be floating at present. No, too greedy that time. It's 38 miles away. So if you were a nucleus, your electrons would be floating, orbiting you about 38 miles, up to 38 miles away. 38 miles from here would be like Portersville or Beaver County for basketball games that we would drive to. That's a ways. Like the city of Pittsburgh from here is not much more than 10 miles. 38, that's a ways. Geneva College would be about that distance, I would say. Yeah, it is.
Smarter than all of us combined.
That's real far.
Me.
Why were you asking?
Oh, I don't know. Have to drag down 70% water.
Homework is 1A to K, 2A, 3A, and the main work is going to be on 5 and 6. Those both go like A to F, but it's not a lot of heavy lifting there, just describing protons, neutron, electron counts. Last call, questions, anything, anybody, buddy? Shut that down.